Welcome, curious minds, to a journey into the heart of the 21st century's most transformative field, data science. In an era overflowing with information, where every click, every transaction, every sensor reading generates an ocean of data, the ability to navigate, understand, and extract value from this deluge is paramount. Data science isn't just a buzzword, it's a powerful discipline that blends statistics, computer science, and domain expertise to solve complex problems and uncover hidden truths. It's about transforming raw, often chaotic data into actionable insights that drive innovation, inform decisions, and predict the future. This isn't just for tech giants, it's shaping industries from healthcare to finance, entertainment to environmental conservation, empowering us to make smarter choices. Our goal today is to demystify data science, giving you a fundamental introduction to what it is, the ecosystem it thrives within, the various roles involved, and most importantly, the mindset you'll need to approach problems with data. Why does data science matter so profoundly today? Simply put, we are living through a data explosion. Think about it, every minute millions of emails are sent, videos are streamed, photos are uploaded, and countless transactions occur globally. This sheer volume, velocity, and variety of data, often referred to as big data, presents both a monumental challenge and an unprecedented opportunity. Without data science, this massive inflow of information would remain a chaotic, unusable mess. Data science provides the tools and techniques to not only organize and process this data but to make sense of it. It enables companies to understand customer behavior, optimize supply chains, personalize experiences, and even discover new cures for diseases. Governments use it to improve public services and analyze trends, while researchers leverage it to push the boundaries of knowledge. The insights gleaned from data are no longer a luxury, they are a strategic imperative, driving innovation and competitive advantage across every sector imaginable. At its core, data science stands on three fundamental pillars. First, we have mathematics and statistics. This pillar provides the rigorous framework for understanding patterns, making inferences, and quantifying uncertainty. Concepts like probability, hypothesis testing, regression analysis, and multivariate statistics are the bedrock upon which data-driven insights are built. Without a solid understanding of these principles, one might mistake correlation for causation or draw erroneous conclusions from noisy data. The second pillar is computer science and programming. This encompasses the technical skills needed to actually collect, store, process, and analyze large datasets. Proficiency in programming languages like Python or R, understanding data structures, algorithms, and working with databases are crucial. This pillar allows data scientists to build, implement, and automate their analytical processes and models. Finally, the third and often overlooked pillar is domain expertise. This refers to a deep understanding of the specific industry or field the data pertains to. Knowing the context of the data, the business problem, or the scientific question helps in formulating relevant hypotheses, interpreting results correctly, and asking the right questions in the first place. Without domain knowledge, even the most sophisticated algorithms can produce technically correct but practically useless insights. The data science ecosystem is a rich and diverse landscape of tools and technologies, constantly evolving to meet new demands. At its heart are programming languages, with Python and R leading the pack. Python is highly versatile, boasting an extensive collection of libraries like NumPy for numerical operations, Pandas for data manipulation, Matplotlib and Seaborn for visualization, and scikit-learn for machine learning. R, on the other hand, is particularly strong in statistical analysis and has robust packages for data visualization like ggplot2. Beyond these languages, data scientists frequently interact with various types of databases, from traditional SQL databases like PostgreSQL and MySQL to NoSQL alternatives such as MongoDB, essential for handling unstructured data. Cloud platforms like Amazon Web Services, Google Cloud Platform, and Microsoft Azure provide scalable computing power, storage solutions, and managed services for machine learning model deployment. Furthermore, specialized tools for data visualization, business intelligence, and big data processing frameworks like Apache Spark are integral components, allowing data professionals to manage and analyze data at immense scales. This ecosystem allows data scientists to move efficiently from raw data to deployable models and impactful insights. Understanding the typical data science workflow is crucial for grasping how problems are approached and solved. While iterations and specifics vary, a general flow can be outlined. It usually begins with problem definition, clearly understanding the business question or scientific hypothesis to be addressed. This guides the entire process. Next is data collection, where relevant data is gathered from various sources, which could involve querying databases, web scraping, or leveraging APIs. Following collection is perhaps the most time-consuming phase, data cleaning and pre-processing. This involves handling missing values, correcting inconsistencies, removing duplicates, and transforming data into a suitable format for analysis. Without clean data, subsequent analyses are unreliable. Then comes exploratory data analysis, where data scientists use visualizations and statistical summaries to uncover patterns, anomalies, and relationships within the data. This informs feature engineering and model selection. Model building involves selecting and training machine learning models or statistical algorithms to make predictions or classify data. This is followed by model evaluation, where the model's performance is assessed using various metrics and validated against unseen data. Finally, deployment and communication involve putting the model into production so it can be used to solve the original problem, and crucially, communicating the findings and implications to stakeholders in an understandable and actionable manner. Within the broader field of data science, several specialized roles have emerged, each playing a vital part in the data ecosystem. The data analyst is often the first point of contact with data, focusing on descriptive analytics, what happened and why. They excel at querying databases, creating reports, and building dashboards to visualize key performance indicators, translating data into digestible insights for business stakeholders. A data engineer is responsible for building and maintaining the infrastructure that makes data available and accessible. They design, construct, install, and test data management systems, ensuring data pipelines are robust, scalable, and efficient, allowing data scientists and analysts to work with clean, ready-to-use data. Then we have the machine learning engineer, who bridges the gap between data science and software engineering. They focus on designing, building, and deploying machine learning models into production systems, ensuring they are robust, scalable, and integrated seamlessly into applications. Finally, the data scientist often encompasses a broader skill set, combining statistical expertise, programming prowess, and domain knowledge to tackle complex, ambiguous problems. They identify trends, build predictive models, and extract deep insights, often engaging in the entire data science workflow from problem framing to model deployment, and importantly, communicating their findings to influence strategic decisions. Beyond the technical skills, a particular mindset is absolutely essential for anyone aspiring to excel in data science. The first crucial trait is curiosity. Data scientists are inherently inquisitive. They are driven by a desire to understand why things happen and what if they try something different. This curiosity fuels the constant questioning of data, assumptions, and results. It's about looking at a dataset and seeing not just numbers, but stories waiting to be told, patterns waiting to be discovered, and problems waiting to be solved. Hand in hand with curiosity is a strong problem-solving orientation. Data science is fundamentally about solving real-world problems using data. This means being able to break down complex, often vague challenges into manageable, data-driven questions. It involves hypothesis generation, experimental design, and iteratively refining approaches until a robust solution is found. This isn't just about running algorithms. It's about thinking strategically about how data can illuminate paths to effective solutions, always keeping the end goal in mind and adapting when initial approaches don't yield the desired results. Another indispensable aspect of the data science mindset is critical thinking and skepticism. It's not enough to simply collect data and run a model. A true data scientist constantly questions the quality of the data, the validity of assumptions, and the robustness of the results. This means being skeptical of initial findings, seeking out potential biases in data collection or sampling, and challenging the output of models. Is the data representative? Are there confounding variables at play? Could the model be overfitting to noise? Critical thinking also involves understanding the limitations of your data and your models, and being transparent about those limitations. It's about not taking data at face value but digging deeper, performing sanity checks, and validating conclusions through multiple angles. This healthy skepticism protects against misleading insights and ensures that the decisions made based on data are sound and reliable. Without it, even the most advanced tools can lead to flawed conclusions and misguided actions. The final, often underestimated, but critically important mindset for a data scientist is effective communication and storytelling. Having brilliant insights locked away in complex models or technical reports is of no value. A data scientist must be able to translate complex analytical findings into clear, concise, and compelling narratives that non-technical stakeholders can understand and act upon. This involves distilling intricate statistical results into easily digestible explanations, often using visualizations as a powerful aid. It's about crafting a story around the data, articulating the problem, explaining the methodology in simple terms, presenting the key findings, and most importantly, outlining the actionable recommendations derived from the analysis. The ability to tailor the message to different audiences, from engineers to executives, is a hallmark of an impactful data scientist. This storytelling capability transforms raw data insights into strategic advantages, allowing organizations to leverage data for genuine innovation and growth. So, you're intrigued and ready to take your first step into this fascinating world. Where do you begin? The good news is that there's an abundance of resources available. Start by building a strong foundation in mathematics and statistics. Online courses and textbooks are excellent for this. Next, dive into programming, focusing on Python or R. Websites like DataCamp, Coursera, Udacity, and Khan Academy offer structured learning paths. Practical experience is paramount. Work on small personal projects. Start by analyzing publicly available datasets from platforms like Kaggle, explore different visualization techniques, and try to replicate existing analyses. As you gain confidence, try to define your own problems and collect your own data. Build a portfolio of these projects, showcasing your code, methodologies, and findings. Contribute to open-source projects, attend webinars, join online communities, and network with other aspiring data scientists. Remember, consistency and a hands-on approach are far more valuable than simply consuming theoretical knowledge. Every small project contributes to your growth and understanding. As with any powerful field, data science comes with its share of challenges and ethical considerations that demand careful attention. One significant challenge is data quality. Real-world data is often messy, incomplete, and inconsistent, requiring substantial effort in cleaning and pre-processing. Another is interpretability. Complex machine learning models, often dubbed black boxes, can be difficult to understand, making it challenging to explain why a particular prediction was made, which can be critical in sensitive applications like healthcare or finance. Ethically, bias is a paramount concern. If the data used to train a model reflects existing societal biases, the model will learn and perpetuate those biases, potentially leading to unfair or discriminatory outcomes. Privacy is another critical aspect. Handling sensitive personal data requires strict adherence to regulations like GDPR and a deep commitment to protecting individuals' information. Furthermore, the responsible deployment of AI and machine learning models, ensuring fairness, accountability, and transparency, is an ongoing discussion. As data scientists, we bear a significant responsibility to use these powerful tools ethically and to consider the societal impact of our work. You've now had a foundational tour of data science, from its core definition and the incredible data deluge driving its necessity, through its foundational pillars of math, computer science, and domain expertise. We've explored the diverse ecosystem of tools, walked through a simplified workflow, and differentiated the key roles that bring data to life. Most importantly, we've delved into the essential mindset, the boundless curiosity, the unwavering problem-solving drive, the critical skepticism, and the vital skill of communication and storytelling. This field is dynamic, challenging, and profoundly rewarding, offering endless opportunities to make a real impact on the world. This is just the beginning of your journey. The path into data science is accessible, but it demands dedication, continuous learning, and a passion for uncovering insights hidden within the numbers. Embrace the challenges, cultivate your curiosity, and start building your skills today. The data is waiting for you to unlock its secrets.